So today we're going to do Lab 21, Grignard Dyes. So we're going to start off by making the Grignard. So the first thing that we're going to do is we're going to take our N-dimethyl aniline. We're going to react that with magnesium turnings and iodine. The iodine serves to activate the magnesium and release fresh magnesium so that the outside that's oxidized gets gone and releases that fresh magnesium, which can then form our Grignard. So we start with our 4-bromo N-dimethyl aniline, react that with our magnesium turnings, which gives us our Grignard compound. And then depending on which compounds you use to react with your Grignard, we're going to make different dyes in this lab. So we're going to make two different dyes. We're going to make a malachite green and a crystal violet dye. So the first one, this one up here, is our crystal violet. We're going to have addition of the Grignard reagent onto this ester carbonyl. And it's going to actually happen 3 times. So we're going to get 3 full additions to form this product here with our magnesium bromide salt. Once we form this product, then we're going to add HCl. What the HCl is going to do is it's going to form this bond, and we're going to get this final salt, but it's also going to act to neutralize any leftover magnesium that we have to form our final crystal violet dye. So very similarly, to make the malachite green dye, we're going to react it with this compound here. This one's only going to add twice. These are 2 additions, leftover magnesium salts, and then we're going to react that with hydrochloric acid, which is going to neutralize the salts and form our final malachite green dye. So in this water, we do want to make sure that everything is water-free, because Grignards do react with water and it kind of shuts down what they do. So in this step, if there is water, the magnesium, instead of reacting with the compound that we desire, it will just react with the water and deprotonate it, effectively making the magnesium null. So we want to make sure that everything's water-free so that the magnesium that we add into the reaction reacts with the brominated compound to form our Grignard. And once we make the Grignard, if there is still water present, it can also react with water. So we just want to make sure everything is nice and dry in order for this reaction to go to completion. So that's everything. Let's get started.
So to begin this experiment, we will set up a reflux apparatus that looks like this. We have a hot plate and a round bottom flask and a condenser that we will put on the round bottom flask after we put all the reagents in. So first we take our 80 milligrams of magnesium turnings and put them inside our flask. Next we add our second reagent, which is the dimethyl aniline. Last, we add a crystal of iodine in order to activate the magnesium turnings. Now we can add our solvent, which is dry DHF, 5 milliliters. Start turning the stir bar and attach the condenser. Make sure that the water is running through the condenser and we can start heating. So once the color changes to this, we can stop the heating, take off the heating block, and replace it with a cooling pot in order to cool the mixture to 0 degrees before we add the second reagent. that our solution is cool, we can remove the condenser, set it aside, and add our solution of a carbonyl compound. In my case, it will be diethyl carbonate, dissolved in 1 milliliter of DHF. Now we will reattach the condenser. Remove the ice bath and put the heating block back on the stirrer. And begin heating the solution again for another 5 minutes. We can turn off the heating, lower the heating block, and replace it with a cooling bath. And wait until the solution cools down. So after our solution is cooled down, we can take 5 milliliters of hydrochloric acid and carefully add it into the stirring solution. And you can see that the color immediately turns into purple as the alkoxide anion gets protonated and water is eliminated. Now we can remove the cooling bath, stop the water flow in the condenser, remove the condenser, take our solution of violet purple, you can see it's a really deep color, and pour it over a beaker with a folded strip of different samples of cloth inside. Oops. I should have taken care not to put the stirring bar inside, but it should not be a problem.
So, very similar to the crystal violet, this is the malachite green. We're going to do the same thing. We're going to add our 5 mils of HCl straight down the condenser. And immediately we see that bright green / teal color form. Once that forms, we can actually take this out of the ice bath, remove the condenser, and then you can see how bright that is. We can pour a couple mils of this straight onto our
Now that our fabric is completely dyed, we can take it off the dyeing solution and transfer it into a beaker with clean water. Swirl it around a bit to wash off the excess of the dye. And pour the excess of the dyeing solution, pour the washed off dye into aqueous waste. You can repeat the procedure in order to remove all of the excess dye. So we add in another portion of water, swirl it in, and pour off the excess. You can see that the fabric is now completely dyed. You can actually see that there are different strips, and it shows us that some kinds of fabric will dye better, other kinds of fabric will not dye as well.
So we're going to repeat the process that we did with the crystal violet dye with this malachite green. So I'm going to try to just shake off any excess dye and then put it in the water. Stir it around. Try to get all that excess dye off. And then dump all that water into aqueous waste. We're going to repeat that process because there's still a lot of dye that's coming off. We can see the different colors that this dyed the fabric.
Now we have dried out the excess liquids to paper towels and oriented the strips of fabrics in a way that the rayon part is at the top and the wool part is at the bottom. And you can see that each type of fabric dyed to a different extent.